Right, this is Sample Physics here again, basically bringing you how to show you how electromagnet works. And you can see from here that basically that when you actually have a nail, for example, which is a simple metal material, and if it's actually wound basically with obviously with a wire that carries a current, the interaction between the current and the metal actually causes the paper clips to be attracted towards this a nail and with the wires that are wrapped around it. And the simple reason for that is because when you actually switch when you close a switch, for example, i.e. this switch here, you will find that basically the current actually does pass through, and the proof behind that is obviously the light bulb actually turns on. Now in doing so, when there is current passing through a coil, the nail actually becomes a magnet. And because this nail actually becomes a magnet due to due to a flow of charge through the wire, you actually call this an electromagnet. How do you produce electromagnets? Because you have a piece of metal, for example iron, and what happens is when you wrap wire around it, i.e. insulated wire around it, the interaction between the flow of charge, and also the metal produces an electromagnet. Obviously this causes the paper clips to be attracted. Now, if we now move on to, let's say, looking at, let's say, a more practical approach, where we now look at also a nail that is wrapped around with an insulating wire with plastic insulation on it, what happens is we can now investigate the strength of the electromagnet. And the way you can do that is by looking at the independent variable. Now, in this case, the independent variable is going to be the number of times you coil the wire around the nail. And obviously now what you're measuring is basically the number of paper clips that you can actually pick up because of the electromagnetic force being generated on the nail. So in simple terms, what happens is that you basically take some insulated wire, you wrap it around the nail, okay, this becomes electromagnet, it picks up paper clips. And to look at that, we can look at the first experiment where we're looking at investigate how the number of coils affects the number of paper clips. And what you're going to find is that you need to keep a control variable, and this control variable is going to be the current, which you're going to keep constant. So this now basically sets a tone where we can actually now increase the number of coils. We can then measure each time the number of paper clips that you basically pick up, and you're keeping the current the same, which is a control variable. So in this case then, we're now looking at the independent variable is going to be the number of coils. The dependent variable is going to be the number of paper clips, and from this we can generate some numbers, and the control variable again is going to be keeping the current the same throughout the experiment. Okay, and obviously then if we now look at the graph itself basically shows you a slightly non-uniform, i.e. slightly curved path, okay, where you actually have a change in the number of clips being attracted, i.e. an increase as you increase the number of coils, okay, from 0 right the way up to say 80 in increments of 20 coils every single time. Now this is one of the first graphs that you need to really sort of get grips with, because it shows you obviously the direct link between the strength of an electromagnet and how you can actually increase it by introducing the number of coils as well. Now this graph is quite particularly important because let's say for example you did 80 coils altogether and you wanted to predict, let's say, what happens to the number of paper clips, let's say 150 coils. So you can almost extrapolate this graph further along like this, all the way up like this on the graph paper. Then you can determine how many paper clips you attract by obviously working your way across the graph and determining basically where it's 150, i.e. number of paper clips, and you can see